guys, Unreal Academy here, and in today's video I'm finally going to start the portal gun tutorial series. In this video I'm going to be setting up the blueprints for the portal gun, the variables and functions that we're going to need later on in the series, and the portal display system. Before we start, please make sure that everything in your level is in the positive axis, which you can set or see from here in the location panel. Also, please make sure that global clipping has been enabled by going to Edit, Project Setting, search for Clip, and just enable support global clip playing for planar reflections. It will ask you to restart. I already have it enabled, so I do not need to restart. So let's start by creating all the variables and the blueprints that we're going to use in our future tutorial series. Open up your character blueprint and create the following functions. Spawn portal 1. In this function we'll spawn the portal 1, and for this we're going to spawn portal 2. Store velocity to store the player's velocity. Destroy portal 1 to destroy the portal 1, and destroy portal 2 to destroy portal 2. Portal 1 collision test to ensure that the portal is spawning in an area with enough space. And now let's create the variables. Create portal 1 vector to store the location of portal 1, and portal 2 vector variable. Create a boolean variable. Name it portal 1 spawned. This will be used to check if the portal 1 has been spawned or not. Another one, portal 2 spawned. And now we're going to create two new rotator variables to store the rotation of portal 1 and portal 2. Change its type to rotator. Now we're going to create two new vector variables and store, in which we'll store the portal 1 and portal 2 forward vector. Change its type to vector. Create another one. We're also going to create two new booleans. Newly created portal 1. Change its type to boolean. Another one for portal 2. Don't worry about what these variables are going to be used for. You're going to find out later in the series. Create a new variable of vector type to store the player's velocity. Change its type to vector and hit compile. Now create a new blueprint of type actor in the blueprint folder. Name it portal 1. Double click to open it up. And let's create the functions for this blueprint. Click the plus button here. Set player velocity. In this function we'll be setting the player's velocity. Set player rotation. We'll be setting the rotation of the player in this function. And reset max acceleration. We'll be resetting the max acceleration after the player has been teleported. Set velocity according to forward vector. This will be an addition to set player velocity. Set location on call. Set portal 1 location on call. This will set the portal 1 location on call. And set render target rotation to set the render target rotation. Hit compile. And now let's create the variables. Click the plus icon. Is second portal made. This will be used for the material is player to check if the player is the one overlapping or it's something else like a static mesh. Portal 1 forward vector to store the portal 1 forward vector. Change its variable type to vector. Create a new variable and call it portal 2 forward vector. This will be used to store the forward vector of portal 2. Collision original location. This will be used to store the original location of the collision. And let's do collision random location. This will be used to store some random location of the collision. Let's set its value to something like 10000 10000 10000. You'll learn why I did this later on. Create a new boolean first run. Change its type to boolean. Hit compile. Velocity addition. Change its type to integer. And now we're going to create rotator variables to store the rotation of portal 1, portal 2, and player's rotation. And hit compile. And now we're going to create a reference to the player controller, and change variable type to player controller and make it an object reference. Hit compile. And now we're also going to create a cast to first person character reference. First person character, an object reference. Hit compile. A set index, variable type integer, velocity addition z vector, and hit compile. Now let's set up the view of the portal 1. Add a component plane, add a scene capture component, and add a box collision and also add an arrow. Move the arrow to 10 units of X. Do the same for box collision, 10 units. Now this is very important. Set the rotation of the plane to be 90 and negative 90 here. Make sure that the rotation of the plane is just as I showed you. Move the camera 10 units forward in the X direction. And let's scale the plane to a size from which your player will be able to pass through. Set its scale to something like 1.25, 2.25, and leave the Z at 1. Set the scale of the box collision to be something like 0.25, 1.5, and 3.25 to ensure that it covers all of this area. Let's rename it. The box collision will be used to teleport the player on overlap. Teleport on overlap. The scene capture component 2D is the player, is the portal 1 view, and keep the plane name as it is. Now I'm just going to duplicate this, right click and duplicate portal 2, open this up, and everything is as it should be. Now the only thing that I'm going to change is I'm going to select this camera and change its name from portal 1 view to portal 2 view and just hit compile. Now everything is working wonderfully. Now let's move on to actually creating the texture target and adding the special effect around the portal. Create a new render target by going to materials and texture and selecting the render target. Name it portal 1 underscore render target. Open it up and set its size X to 19201080. This will be the size of your resolution. Hit save and just create a material from this. Open it up. Now let's add the sides of this render target. Plug in a screen aligned UVs into the UV of the texture sample. Now instead of using a texture sample, use a 2D texture sample. Right click here and search for texture sample parameter 2D. Just use this texture sample, set its name to texture sample, and plug in the screen aligned UVs into the UV of this 2D texture sample. Change the texture to the render target. Let's see, portal 1 render target, and drag this node out here and search for screen resolution. So visible resolution into the texture dimension, X 100%, Y 100% into the UV of the texture's 2D sample. Now select this result node of the material, select the result node of the material, and in the blend mode set it to masked, and in the shading model set it to unlit. And hit save. Now I'm going to use this texture here to animate the sides of my mesh, but you can use whatever texture you want. I'll also try and upload this texture somewhere so that you guys can download. Multiply this by a constant 3 vector. So basically this will get multiplied by a color, and the output will be the color of the portal. So if I want to make my portal say orange, hit OK, and I'm also going to add a noise to the side of my texture. Search for texture coordinate, plug it in to the rotator, and create a new texture sample, and search in the texture, just change its type to noise. Search for noise and you'll see this T-purling noise, which is included by default with the engine. Plug in the coordinate result you pin into the UV pin of the texture sample. And now let's search for blend overlay and plug in the multiply node into the top base version 3 and the RGB of this noise texture sample into the blend version 3. What you're going to do is drag this node out here and search for lerp, and in the math tab just click on the linear interpolate. We're going to plug in this blend overlay result into the alpha, as well as the opacity mask and the opacity of this texture, and plug in the lerp1 pin into the emissive color of this texture. Multiply the B node with any number you want and it will set the brightness of the portal. I'm going to set it to 100. Now you can see that the sides are eliminated as well. We do not want that. So I'm just going to drag out this pin of the blend overlay and search for 1 minus, and then just plug this in to the opacity mask as well as the opacity and hit save, and this will be the result. Now we have a working portal texture. Hit save, go to portal 1 blueprint, select your camera, and scroll down till you see scene capture, and in the texture target, change the texture target to portal 1 render target. Hit compile. Now browse to where you stored the portal 1 material, render target material, as well as the portal 1 render target. Right click and duplicate this, rename it to portal 2 render target, duplicate this as well, and rename it to portal 2 render target material. Save all, save selected, open up the portal 2 render target material, and select the texture sample parameter 2D and change the texture to portal 2 render target. Hit save, change the color to anything you want. I'm going to use white. Okay, and save. So now open up your portal 2 blueprint, select the camera, and change the texture target to portal 2 render target. Hit compile, and select the plane mesh and change its material to portal 1 render target material. Since we want to display what's in front of the portal 1 on portal 2, this is why we're going to use the portal 1 render target material on portal 2 and use the portal 2 render target material on portal 1. Hit compile and hit compile. Now let's see if it works. Go here and here, move it above. I'm going to rotate this opposite and add a cube in front of this, and add a sphere in front of this. And now if I hit play, okay, so now you'll see that I'm seeing that sphere over there in this render target, and seeing the sphere and the ball on this render target. Now there is one problem, which is we do not want collision to be enabled in the portal or in the plane mesh of the portal. So open up the blueprint, portal 1 blueprint, select the plane mesh and scroll down, collision preset, no collision. Hit compile, do the same for portal 2, scroll down, collision preset, no collision. Hit compile, and now it should work. Now we should have no collision at all. Now if I hit play, you can see I can go through the portal. However, there is one problem. The portal system moves with the player rotation. We do not want that. We want to keep this image here static and only move when the player moves and not move when the player rotates. To fix this, here's what you're going to have to do. Go to your portal blueprint directory, open up portal 1 blueprint, and now open up the set render target rotation function. Once you open it up, drag out this node player rotation rotator variable here and set the rotation. Right click get player camera manager, return value, search for get world rotation, and plug in this return value and store it in the player rotation variable. Now we need to set the portal 2 forward vector. Drag out this node here and set portal 2 forward vector, and now cast to first person character, get cast to first person character, and get the portal 2 forward vector, plug it in here, and drag out this portal 2 forward vector node, and get portal 2 forward vector node, split its structure pin. Now we're going to check, do a branch check, that if it's equal float, and if it's equal 1, which means its forward vector is the x-axis, do a branch check, branch. If it's true, we're going to get the player's rotation, get player rotation, split the pin structure, get the z value, subtract it from 180, like this. Now multiply the return value by an integer, -1, set the integer to be -1, and now drag out the portal 1 view and drag out this portal 1 pin and search for set relative rotation, split the pin structure, and plug in this return value of the multiply node into the z value of this node. Now if this condition is true, we're going to get the player's rotation, subtract it from 180, and then multiply the result by -1. If it's false, we're going to do another branch check to see if the player is facing the negative x-axis. If the condition is true, we're just going to copy all of this and paste it here. If it's true, just execute this. And instead of subtracting 180, we're going to keep the portal rotation relative to player's rotation. Hit compile. Another branch check. Branch. This time we're going to check for the y-axis. Let's say equal float. If the forward axis of portal 2 is equal to 1, it will mean that the portal is facing the y-axis. If this is true, we're going to copy this code here, paste it here again. If it's true, we're just going to subtract the player's rotation from -90 and then multiply the result by -1. And if it's false, we're going to do another branch check. If it's equal to -1 condition, so if the portal is facing the negative y-axis, if it's true, we're just going to paste the same thing here, plug in the true to the execution point of set relative rotation. Instead of subtracting from 180, we're going to subtract from 90. So player's rotation subtracted from 90 multiplied by -1, and that will set the portal's rotation. Let me just clean this up. Also plug in the statement to the branch statement. And now hit compile. So now we're done. Now copy all of this and open up the Portal 2 blueprint. Open up the set target rotation function and paste all of this here. And this time the only difference is instead of getting Portal 2 forward vector, we're going to get Portal 1 forward vector. And delete this. And instead of setting Portal 2 forward vector, we're going to set Portal 1 forward vector. Delete this, plug in this here, and this inside this. Execution into the branch statement, and hit compile. You'll see that we cannot compile. This is because we're referencing portal 1U, which is only present in portal 1. Just change this by dragging and dropping this portal 2 view onto the portal 1 view. It will automatically replace. And also instead of portal 2 forward vector, we're going to get portal 1 forward vector and drag and drop it on this. Press Ctrl and drag the pin into X. Press Ctrl and drag the pin into Y. Now hit compile, and let's see if it works. I'm going to hit play. Now it's not working because we have not called it in the event graph. Go to event graph and call the set render target in the event tick. Hit compile. Do the same here. Go to event graph, call the function set render target, and just hit compile. Save all. Save selected. Play. Okay, it's trying to access none, trying to read cast to first person character. I think this happens because we have not set. Drag out this node here and set cast to first person character. Event begin play, we're going to define what cast to first person character is. Just search for cast to first person character as get player character. Now we're going to set its value to this. And now if I hit compile, do the same here. Portal 2 event graph, event begin play. And if I hit compile now and hit play, it still doesn't work. This is because it doesn't work because the player is not getting the forward vector of the portals. So we're just going to open up the player's blueprint. In portal 1 forward vector, we're going to set the portal 1's forward vector. So in our case, the forward vector of portal 1 is the x-axis. So we're just going to change the x of the portal 1 forward vector to 1. Hit compile. And since the portal 2 is facing the negative x-axis, we're going to change the portal 2 forward vector to -1 and hit compile. Compile here as well. And if I hit play now, you can see that it does not rotate as much. If I were to teleport right now, I would teleport looking at this ball here. Same thing for this. It does not happen as much. Here's how it would look like without having its rotation set according to player's rotation. But when we set the render target's rotation according to player's rotation, this is how it looks like. It doesn't move nearly as much. It is very expensive because even a GTX 1060 cannot run this above 60 frames per second on a simple scene. So I can see how this might be a problem for some people. You can disable this, however, it will not look half as good with it disabled. So that's it for today's video. Hope you guys enjoyed it. And in tomorrow's video, I'm going to be showing you how to spawn the portals where the player is pointing and set the rotation of the portals accordingly. See you guys in my next video. Bye.